So welcome to today's session on development of blood vessels. So development of blood vessels, we can give two terms as vasculogenesis and angiogenesis. So blood vessels develops by either vasculogenesis or angiogenesis. Vasculogenesis is the process of formation of a new vessel by coalescence or fusion of angioblasts. These angioblasts are specialized mesenchymal cells. So here in this image you can see the development of blood vessels which are from the mesenchymal cells forming the clusters. So this process is the vasculogenesis, and the mesenchymal cells differentiate into angioblasts which are vessel forming cells, and that aggregate to form an isolated angiogenic cell clusters of cords. So you can see the cell clusters or cords. So these cell clusters or cords are derived from the angioblast cells, and the lumen later it appears in these clusters and cords, and primitive blood vessels are formed. So we can see the formation of primitive blood vessels. So here is an embryonic disc showing from the dorsal view and explaining the development of cell clusters and or cords of cells which forms the primitive blood vessels. So the angioblast they later flatten to form endothelial cells that arrange themselves around the cavities in the clusters, and cords to form the endothelial lining of the blood vessels. The primitive blood vessels get interconnected with each other to form a network of endothelial vascular channels. So we can see the interconnections forming endothelial vascular channels. Which are termed as blood vessels. So because of hemodynamic and genetic factors, certain channels enlarge to form blood vessels, and channels connected to them form the branches or tributaries, while the other channels will disappear and disintegrate. So the next process by which a new blood vessel develops is the angiogenesis. Angiogenesis is by budding and branching from the pre-existing vessels. So the vessels sprout into the surrounding areas by endothelial budding and fuse with the other vessels. So here we can see the budding and branching also from the vessels. So this is the primitive heart tube. And here is the sagittal view of the embryo showing amniotic cavity, yolk sac cavity. And we can see the blood vessels which are budding from the existing blood vessels. So the vessels sprout into the adjacent areas by endothelial budding and fuse with other vessels. In this process, it results in a permanent vascular system. So finally we get a permanent vascular system. So the primitive blood vessel cannot be distinguished structurally as arteries or veins. However, they are named according to their future fate and relationship with the heart. So let's see the mesoderm which gives rise to these blood vessels. There are two varieties of mesoderm which we know in general embryology, that is in extraembryonic and intraembryonic mesoderm. In extraembryonic mesoderm, vasculogenesis occurs first within the extraembryonic visceral mesoderm around the yolk sac on 17th day. So this is the yolk sac. So we can see the blood vessels around the yolk sac which develop by vasculogenesis. By the day of 21, the vasculogenesis extends into extraembryonic somatic mesoderm, which is located around the connecting stalk to form the umbilical vesicles, and in the secondary villi, and also which turns to form the tertiary villi in placenta. So further they form the umbilical vesicles in the connecting stalk. So these are the umbilical vessels which develop around in the connecting stalk. So vascular genesis occurs by a process in which the extraembryonic mesoderm differentiates into angioblast, which form clusters known as angiogenic cell clusters, and these angioblasts located in the periphery of angiogenic cell clusters gives rise to endothelial cells, and which fuse with each other to form a small blood vessels. So that was about the extraembryonic. Next, about the intraembryonic mesoderm. Blood vessels form within the embryo by the same mechanism as in the extraembryonic mesoderm. So the same process of vasculogenesis occurs even in the intraembryonic mesoderm. Eventually, the blood vessels formed in the extraembryonic mesoderm become continuous with the blood vessels within the embryo, so thereby establishing a blood vascular system between the embryo and the placenta. So the next thing which we are interested to know is about hematopoiesis, means blood cell formation. So first blood cell formation, hematopoiesis, occurs within the extraembryonic visceral mesoderm around the yolk sac. So around the yolk sac we see the first process of hematopoiesis, that is the formation of blood cells, and that is during the 3rd week of development it occurs. And during this process, angioblast within the cell center of angiogenic cells clusters gives rise to primitive blood cells. At the beginning of 5th week, the hematopoiesis is taken over by a sequence of embryonic organs like liver, spleen, thymus and bone marrow. So that was about the development of blood vessels and blood cells. Next we shall look upon veins associated with tubular heart. So during 4th week, there are 3 paired veins appear which drain into the venous end of the tubular heart. So that is the sinus venosus of the tubular heart. So here in this image, this end is the sinus venosus. So we can see the veins draining into the sinus venosus. So those 3 sets veins we can classify into umbilical veins. So the umbilical veins carry the blood from the placenta. So here are the umbilical veins. So umbilical veins we see they carry the oxygenated blood. So the blood is well oxygenated from the mother. So the right vein degenerates among these umbilicals. The right vein will degenerate. Only left vein forms the ligamentum teres hepatis in adults. So that is about the umbilical veins. The next category of veins are vitelline veins, which follow the vitello-intestinal duct, that is from the yolk sac. So here is the vitello-intestinal duct which communicates with the gut. So the veins are surrounding the vitello-intestinal duct draining from the yolk sac. So the right vitelline vein forms the hepatic veins and sinusoids and ductus venosus, hepatic portal vein and superior mesenteric vein, inferior mesenteric vein, splenic veins and part of inferior vena cava. So those are the derivatives of right vitelline vein. So these are all vitelline veins. So vitelline veins we can see they are draining from the yolk sac. So the right vitelline vein will form the that is so many structures, that is they form the hepatic veins, sinusoids of liver and ductus venosus present in the liver, which is in adult called as ligamentum venosum, and hepatoportal circulation veins present between hepatic and portal veins, and superior mesenteric, inferior mesenteric, splenic veins, and also it forms a part of inferior vena cava. Whereas the left vitelline vein forms the hepatic veins and sinusoids and ductus venosus. So that was about the vitelline veins. The third category is common cardinal veins, drain poorly oxygenated blood from the body wall of the embryo. So the common cardinal veins usually drain from the body wall. So you are seeing these small branches. These are the, and this branch, larger branches here also. These are cardinal veins. So these are the cardinal veins which drain poorly oxygenated blood from the body wall of the embryo. So the common cardinal veins are formed by joining anterior and posterior cardinal veins. Anterior cardinal vein forms the internal jugular vein and superior vena cava, and posterior cardinal vein forms a part of inferior vena cava and common iliac veins, and subcardinal vein which forms the part of inferior vena cava, and also the renal veins, gonadal veins. Supracardinal veins forms a part of inferior vena cava, intercostal veins, azygous and hemiazygous veins. Vitelline veins develop from the portal system. Umbilical veins usually degenerate after birth, and vitelline and umbilical veins are together considered as visceral veins. Cardinal veins which develop from the caval system, that is superior vena cava and inferior vena cava, and cardinal veins forms the somatic veins. The interconnections between the veins leads to enlargement and regression of these veins, resulting in the formation of portal system, caval system and azygous system. So let's start with the visceral veins, that is the right and left vitelline veins. So first we shall begin with the development of visceral veins. Visceral veins, we know they are like vitelline veins and also the umbilical veins. So first we shall talk about the vitelline veins. Right and left vitellines and also the right and left umbilical veins drains the blood into corresponding horn of sinus venosus. So this is the sinus venosus. So here is the sinus venosus. This is the left horn of sinus venosus, and here is the right horn of sinus venosus, and we can see the vitelline veins and umbilical veins opening into. So the medial veins, these are vitelline veins, and umbilical veins. So the vitelline veins arise from the yolk sac, and initially they pass from the yolk sac to the sinus venosus, and when the yolk sac disappears, these veins pass on either side of the duodenum to form plexus around the duodenum and open into a corresponding horn of sinus venosus. And before opening into the sinus venosus, they pass through the septum transversum. So this is the septum transversum. So these veins, they pass through the septum transversum, which before opening into the sinus venosus. And with the appearance of the hepatic bud in the septum transversum, the proximal parts of the vitelline and the umbilical veins which are present in the septum transversum forms fragmented into small channels which are blood-filled gaps which are called as sinusoids. So we can see here, they get disrupted and they get divided within the septum transversum, forming a blood-filled gap called as sinusoids. So here is the hepatic bud which is developing within the septum transversum. So the sinusoids of the liver drain the blood through the persistent terminal parts of vitelline veins. The parts of vitelline veins distal to the liver sinusoids forms the right and left hepatocardiac channels. So these forms. So they form these hepatocardiac channels which drain into the corresponding horns of sinus venosus. So this is the sinus venosus. So the left horn of the sinus venosus undergo regression and gradually the left hepatocardiac channel disappears and disintegrates. So this is the right hepatocardiac channel which is persistent, and the left is not there because it disappears and disintegrates. That was about the left horn of sinus venosus. So the regressed part of left horn of sinus venosus forms the medial part of coronary sinus, which drains the major part of heart into the right atrium. So due to the regression of the left hepatocardiac channel, the blood from all the vitelline and the umbilical veins drain into right hepatocardiac channel. So this is the right hepatocardiac channel, which is draining all the blood from both umbilical and vitelline veins from all sides. So the right hepatocardiac channel is also known as common hepatic vein, and this vessel from the terminal part forms the terminal part of inferior vena cava. So this part forms the termination of inferior vena cava. So inferior vena cava develops from 6 sources. So this common hepatic vein forms one among the 6 sources which gives rise to inferior vena cava. So here we can see the developing liver, terminal part of inferior vena cava. So the next set visceral veins are the umbilical veins. Initially there are 2 umbilical veins which I have already shown. So there are 2 right and left umbilical veins. They arise in the placenta and course through the umbilical cord and enter the fetal body through umbilicus. They carry the oxygenated blood from placenta to the fetus and open into the right and left horns of sinus venosus respectively. So just like vitelline veins, they too open into right and left horns of sinus venosus. So with the development of liver in the septum transversum, the umbilical veins are absorbed and broken up within the septum transversum. So just like we saw how the vitelline veins were also getting broken up to form sinusoids, here also the umbilical veins will open up. So this is the right umbilical vein and this is the left umbilical vein, and these are the vitelline veins. And the parts of the umbilical veins distal to the septum transversum and the remainder of right umbilical vein disappear so that only the left carries the blood from the placenta to the liver. So only the left one carries the placenta blood to the liver. And when there is an increase in the placental circulation to facilitate rapid transportation of blood through the liver. In order to facilitate the passage of blood through the liver, some sinusoids of liver they get enlarged and they get joined to create a new connection between the left umbilical vein and common hepatic vein. So between the left umbilical vein and common hepatic vein, so this is the common hepatic vein. So between the left umbilical vein and common hepatic vein, the connection is called as ductus venosus. And this ductus venosus which forms ligamentum venosum in adults. So the right umbilical vein it disappears and all the oxygenated blood from the placenta is brought by the left umbilical vein alone. So the left vein is on the left. So remember, left is only the vein which is left, and right umbilical vein is degenerated and disappeared completely. So while these changes are occurring within the liver, the parts of right and left vitelline veins, infrahepatic part, undergo alterations to form portal veins. So after visceral veins, let us move on to somatic veins. Somatic veins are otherwise called as cardinal veins. So each horn of sinus venosus receives common cardinal veins, which are otherwise called as duct of Cuvier. So there are right and left common cardinal veins which drain into right and left horns of sinus venosus. So this is sinus venosus receiving right and left horns from right and left common cardinal veins. This is right common cardinal vein. This one is the left common cardinal vein, which opens into each horn of sinus venosus. And each common cardinal vein receives blood from the anterior and posterior cardinal veins. So, this is anterior and posterior cardinal veins. So, the right common cardinal vein receives the blood from the right anterior and right posterior, similarly on the left side. And anterior cardinal veins drain the cranial part. So, if you see the anterior cardinal veins, it drains the cranial part of embryo, and posterior cardinal veins drains the caudal part of the embryo. So, let's talk about anterior and posterior cardinal veins, which receive series of intersegmental veins that drain the various segments of the body. So, the intersegmental veins in the region of upper limb bud enlarge to form subclavian vein. So, subclavian vein develops individually, which drains the developing upper limbs. These veins join with the anterior cardinal veins on either side. So, we can see the subclavian veins. So, both right and this is the left subclavian veins, which are draining into draining the upper limb and draining into the anterior cardinal veins on each side. Soon the right and left anterior cardinal veins becomes interconnected by an oblique anastomosis just caudal to the subclavian vein connection. So, this is the oblique anastomosis. So, this one is the oblique anastomosis connecting both right and left anterior cardinal veins. So, this anastomosis, it is just caudal to the connection with the subclavian vein, you can see in this image. And the left common cardinal vein and left anterior cardinal vein till the oblique anastomosis and the left posterior cardinal veins will regress. So, what are the structures which get regressed here? Is the left common cardinal vein. So, the left common cardinal vein is regressed here. Then, left anterior cardinal vein till the oblique anastomosis. So, the left is till the oblique anastomosis. So, this part would get regressed. And also the left posterior cardinal veins will regress. So, there is no left posterior. So, this is the left posterior cardinal vein, and this one is the right posterior cardinal vein. So, left posterior cardinal vein also regresses. So, that's how about the cardinal veins. Next, we shall learn about the development of major blood vessels in the upper part of the body. We shall start with the development of superior vena cava. Superior vena cava is derived from the right anterior cardinal vein caudal to the oblique anastomosis. So, here is the right anterior cardinal vein. This one is the right anterior cardinal vein. So, just caudal to the anastomosis forms, that is caudal to the oblique anastomosis is the superior vena cava, which is from the right common cardinal vein, and the right horn of sinus venosus forms the part of right atrium. So, the superior vena cava opens into the right atrium of the heart. So, this right horn will form the part of right atrium, so that this superior vena cava, that is the right anterior cardinal vein which is existing here, it opens into the right atrium of the heart. So, we can see the further development. This is the right common cardinal vein. and you can see that right horn of sinus venosus is getting absorbed to form superior vena cava. This is the right atrium of heart. So developmentally, superior vena cava consists of two parts, first and second part. First part develops from the right anterior cardinal vein caudal to the oblique anastomose. So this one is right anterior cardinal vein caudal to the oblique anastomosis. So this is the oblique anastomosis. And the second part develops from the right common cardinal vein. So this is the right common cardinal vein. This is right anterior cardinal vein. So these are the two sources which gives rise to the superior vena cava. As the right common cardinal vein opens into the right horn of sinus venosus, the superior vena cava at first opens into the right horn of sinus venosus. As and when the right horn of sinus venosus is absorbed into the right atrium, the superior vena cava finally opens into the right atrium. So that was about the development of superior vena cava. Next we shall move on to the development of brachiocephalic veins. So the right brachiocephalic vein is derived from the right anterior cardinal vein between the entry of right subclavian vein and oblique anastomosis. So this is the oblique anastomosis. So this is the entry of subclavian vein, right subclavian vein. So this from here to here is the right brachiocephalic vein. It is right brachiocephalic. Next about the left brachiocephalic vein, it is derived from the left anterior cardinal vein and oblique anastomosis. So below the opening of subclavian, left subclavian, this is left subclavian vein. From here, along with this oblique anastomosis, will form the left brachiocephalic trunk. So left brachiocephalic vein is derived from the left anterior cardinal vein and oblique anastomosis. Next about the internal jugular veins, they are not derived from the cardinal veins. These arise from this as a secondary venous channels from the brachiocephalic trunks. So most of the veins on the left side, they undergo regression. That is the caudal part of anterior cardinal vein, so which is also regressed, and also the greater part of posterior cardinal veins regress to form the left superior intercostal veins, and the left common cardinal vein and the left horn of sinus venosus regress to form coronary sinus. So till now we have seen about the anterior cardinal veins and how they regress and they form the veins of the upper part of the body. Let's talk about the fate of posterior cardinal veins. So the cranial part of these veins joins with the anterior cardinal vein to form common cardinal veins. So we know that cranial part of it. So this is the anterior cardinal veins and these are posterior cardinal veins. So they on each side they form common cardinal veins. So this is right, left. So the caudal part of these veins receives the veins developing from the lower limb, that is external iliac vein, and the veins from the pelvis, that is internal iliac veins. So the right and left posterior cardinal veins are interconnected by transverse anastomosis. So right and left posterior cardinal veins are interconnected by transverse anastomosis. So along with this we see the development of subcardinal veins. So these veins develop in relationship with the mesonephrons, that is the developing kidneys. So they connect the cranial and caudal part of the subcardinal veins, which communicate with the posterior cardinal veins. Okay. So these are the subcardinal veins which communicate on the cranial and caudal part of posterior cardinal veins. At the level of developing kidneys, the two subcardinal veins, that what you are seeing, this right and left subcardinal veins, these veins, they are interconnected by this anastomosis. So this anastomosis is called as transverse intersubcardinal anastomosis. So this one is transverse. So it is transverse subcardinal veins, establishes anastomosis with the common hepatic channel that is called as right hepatocardiac channel. So we can see this one is here is the right hepatocardiac channel. So which is seen only on the right side. Next is the appearance of supracardinal veins. Supracardinal veins are also called as thoracolumbar veins, which form between the posterior cardinal and subcardinal veins. So these are subcardinal veins. This is the posterior cardinal veins, and the veins which are intervening here, these are supracardinal veins. So these veins also gain communication with the posterior cardinal veins at their cranial and caudal ends. So you can see their communication with the cranial and caudal ends on each side. So these supracardinal veins also communicate with the subcardinal veins through anastomosis which arise just below the renal veins. So here is this anastomosis on each side is between the supracardinal veins and subcardinal veins. Most of the longitudinal channels regress and disappear, and the veins that remain develop into inferior vena cava, veins of gonads, suprarenal veins and renal veins. So these are the veins which develop from these veins, cardinal veins. So let's talk about the summary of inferior vena cava. So here is a schematic image which is easy for you all to understand how the inferior vena cava developed from 6 sources. So starting from the caudal to cranial, so the lowest part of the right posterior cardinal vein, that is the part between the transverse anastomosis of the posterior cardinal and the junction of right supracardinal vein. So this one. This is the first source. The second source is the lower part of right supracardinal vein, that is the part between its junction with the posterior cardinal vein and anastomosis of the supracardinal vein and subcardinal vein anastomosis. Third source is the anastomosis, that is the right supracardinal and subcardinal anastomosis, this one. Fourth source is right subcardinal vein, that is the part between the supracardinal and subcardinal anastomosis and between the right subcardinal vein and hepatocardiac channel. And fifth source is that is subcardinal hepatocardiac anastomosis. So subcardinal vein and also hepatocardiac anastomosis. And the sixth source is right hepatocardiac channel, that is the common hepatic vein, which opens into the right atrium of the heart. So this completes the development of inferior vena cava. And let's see the development of common iliac veins. So the right common iliac vein is derived from the most of the caudal part of right posterior cardinal vein, which is from the caudal part of right posterior cardinal vein. Whereas the left common iliac vein is derived from the anastomosis between the right and left posterior cardinal veins. So this one. This anastomosis gives rise to left common iliac vein. From here is the left common iliac vein. Now let's talk about the development of renal veins as well. So starting with the right renal vein, it is a mesonephric vein which originally drains into subendocardial veins, which later forms a part of inferior vena cava. So this one I am talking about, and here is the inferior vena cava. So this forms the right renal vein. So the left renal vein here, this is the left renal vein. So it is also a mesonephric origin, originally drains into left subcardinal vein. So the left renal vein is derived from the small part of left subcardinal, that is the point where it drains, and the intersubcardinal transverse anastomosis. So from here to here is the transverse anastomosis. So intertransverse subcardinal anastomosis. So intersubcardinal transverse anastomosis also gives rise to left renal vein. So the left veins are having a longer course than the right veins. Next, about the suprarenal veins, which are the remnants of the part of subcardinal veins above to the intersubcardinal anastomosis. So above to the intersubcardinal anastomosis, this is the subcardinal anastomosis. So above to this, okay, so here in this image we can appreciate the renal veins. So this is the right renal vein. Here is the left renal vein. And here is the right suprarenal vein. This is the left suprarenal vein which drains. So right renal vein, suprarenal vein is draining into inferior vena cava, and whereas the left suprarenal vein is draining into renal veins. So this explains why the right suprarenal vein drains in directly into the inferior vena cava, and whereas the left suprarenal vein drains into left renal vein. Next, about the development of gonadal veins. Gonadal veins are the remnant of the part of subcardinal veins. So the subcardinal veins, so this dotted on right and left side, subcardinal veins gives rise to gonadal veins. So the gonadal veins, you can see they are the remnant of the subcardinal veins below the intersubcardinal anastomosis. So below this anastomosis, the rest of the subcardinal veins gives rise to gonadal veins. This also explains that the gonadal veins on the right side drain directly into the inferior vena cava, whereas on the left side they drain into the left renal vein. So you can see here, this is the right gonadal vein and this is the left gonadal vein. Okay, let's talk about some congenital anomalies associated with the development of these cardinal veins. So first is the double superior vena cava. Persistence of left cardinal vein result in the left superior vena cava. So here is the present as superior vena cava. So left cardinal vein is present here, resulting in left superior vena cava. And the anastomosis between these two anterior cardinal veins to form the left brachiocephalic vein is usually small or it may be absent. So here it is shown in dotted lines which is absent. So the abnormal left superior vena cava opens into the right atrium through the coronary sinus. So you can see it is opening into the right atrium through coronary sinus. So the next condition is the absence of hepatic segment of inferior vena cava. Hepatic segment fails to form as a result that the inferior parts of the body drains into the right atrium through azygous and hemiazygous and also through hepatic veins which open separately into the right atrium. So they open it separately into the right atrium instead of opening in via the inferior vena cava. So the next condition is the double inferior vena cava. This is a rare anomaly which may result due to the failure of anastomosis between the posterior cardinal veins, and that result inferior part of the left suprarenal cardinal vein is persistent here. As a result, it forms a second inferior vena cava. So I am saying there is a failure of anastomosis between the posterior cardinal veins. So what happens? The inferior part of the left supracardinal vein is persist, resulting in second inferior vena cava. So these are the congenital anomalies associated with the development of cardinal veins. Thank you.